Today we are going to see how to transform bond graph models into block diagram models, or maybe you could say block diagrams from bond graph models for mechanical or rotational systems for this example. So what we're going to do is you have a model in there and you have an example, a derivation of how that should be. So we have the bond graph complete over here, and so now we are going to just follow the causal marks and the power flow marks and draw the block diagram. So we will go over here to the right hand side and see if we could actually give us some more space so that so we are going to draw the block diagram for this. So what we need to do is first we need to lay out the structure of this, and so we will do this for the bond on the left, then we do this for the other bond right here, that one, and then we need to set something for the bottom one right here, and then still for the accommodating this sum of efforts and flows. So we have laid out the one on the left. We need to do the stuff on the right hand side. So there's the 0 in here, and then we need to, you have the 1. Now this is the 0 that I just drew. And then we are gonna draw it for the ones on the, so what do we have in here? 0, we have this 1 in here, we have this the one over here, it has the inertia element right here, so that corresponds to this, and then we have the 2 signals, and then this is the 0 junction that you see in there, and that is going to have all this structure in here, and right here it'll be like this. and then we have to have the connections for the one on the right. Okay, so we have the structure, except we're missing something here to the right hand side. You see this one, is represented here. This is the one junction, this is the zero junction, this is the other. No, here's we are short of some graphs. So this is the zero junction in here. This goes down, so this is a one, this is the other one. How come we have two? So this is number 15 and this is 18. Okay, so this is the one junction in there. So we just have one like this, not two. See, one and then the zero and then the one up. Here you have on this one, I forgot the source of effort, and on the other one we don't have anything. Yeah, and here you have the source of flow. The left is also source of flow. So once you have laid out the structure of this bone graft model, you need to go and do the constitutive equations of each one. So, and put it into pictures. Okay, so let's just do the ones that we can do here. So what we're doing is we're going to put all the constitutive laws that we know. SF 1, and then you have in here is the signal goes from right to left. So this is an example. Here you have the let's see, that is this one. I am missing something in here. I'm missing the other inertia. This one, in fact, I think what happens is, I knew there was something funny about the number of bonds. This one is like that because this one is this, and then we have this over here, then we have right here, yeah. So we have this. I need to change the pen because I'm missing two here.
Go over.
Right here, right?
No, next
one more, right here. This right there. I'm missing this. This is the one. I knew there was the zero here, but I messed it up. So let's just delete those lines, because right now we need to draw it with the blue pen. We still need to write in here. There we go. Now we have the entire structure here.
Don't you need one more on the right side?
I think so. We need one more over here, and then we have, yeah. All right, why don't we start doing what we need to do? So we laid out the structure, and the next step is to write the constitutive equations and in graphical form here. And this is what I had asked on the exam. So let's just do this here. What we have is, this is a one junction. This is, we need to put the labels for this. I think it would be a good idea to do this one. This is like E1 and F1. And this is going SF1 is.
I think there's another gap on the left. You have a one junction and zero junction on the left. You only have one gap there.
You combine the one on the left side and get a zero on the right.
Yeah, we could do that. So here we have, this is number 2, E sub 2 and F sub 2. And this is, you know, the I doesn't have a number, so we need to give it a number. We'll wait until the end then, so we don't mess up all the other sequences. So that is going to be, yeah, we don't have the number in here. This is flow, and this is an effort number 13. Is it 13? Yeah, so this is total, I think it's, we're up to number 18, and since I forgotten to do this, I'm gonna put this on 19. So this is E19 and F19. This is, so in 2, the effort goes to the left, the flow goes to the right. And on the other side, you have the force goes this way. No, when it goes like this, then is the 1 is over here. One is, let's see, this is for E2 and E. I'm missing another one too. See number 20 here. Nobody missed. See, this is number 20. And that is number 7, and well, how come I put 2 here?
You're okay.
Yeah, but this is number 7, right?
No. You combined.
I combined the 1
You made
and 2.
So that's okay.
Yeah. And then these are 19 on the top, and this is number 6. And this would be the effort on 6 is going like this. This would be flow 6. And then on the top over here, that one, this is E sub 10, and you can see this goes this way, F sub 10, and then you have the I element, which the effort is the one that is E11, and F11 is this way. This other one, E. Okay. I think we need to do it consistently. We're gonna put this element in here. So first we go and do this, and the second thing we do is to put the number 12 . This is E12 and F12. Yeah, we're not paying attention to the arrows yet, although we could. You know, like this is E12 is obviously like this, and the other one would go like this. Now let's take a look at the bottom one and leave it like that to see what the causal mark says. It says that on this bond number 3, this is sub 3 and an F sub 3, and it says that F3 goes this way and E3 goes this way. On number 4 you have that this is E sub 4, and then you have F sub 4. And then for the resistor in there, this is E5, and F5. And then you have the 8, 9, and so on that we need to keep assigning. We don't want to fall. See, this is 5. Then we have 8 and 9, and then you know that E sub 8 is like this, and F sub 8 is like that. The one on number 5, the effort is this way, and this is like this. Okay, so once we have this, we need to complete the directions in here. This is E sub 8, and according to this goes this way, and this F sub 8. Okay, I think we still continue. We need to continue doing this. For the 1 is 11, 12, and 13. 13 is the internal bond. Yeah, this one is E13, F13. If this other one,
15.
E14 and F14. This would be E16 and F16. And this other one is E17 and F17. And then this would be the number 9. On the bottom, this would be E9 and F9. We have laid out the structure for all of the models. This was 15 and 18. Let's see, we have. Okay, we still have just these two on the. So this is 15. E15 and F15 and E18 and F18. This is obviously like this because this is source. So now what we need to do is to, once we put the structure, let's just do the other things. So let's just go in here, and I'm gonna go from left to right. So in here you see on the first junction I combine those two. So the F4 junction is what goes in like this. Yeah. And this other one goes like this. Now in this case you have, this is E1 and E sub 2. So all the in here, all the, I have to press the 1. All the efforts have to be the same. Okay, so this one is as if you connect this to here and this to here. All efforts are in the same. And then for the flows is F, and on this is 2. You can see this is the flow this way and the causal mark this way. Okay, and then we go to the see, in here we have that this will have to add. So you add all this, but the equation in there is like E sub, like F sub 3 is F2 minus F2 minus F sub, this is a 3 in here, right there.
Yes.
Yeah. So F1 is F3, F2 minus F3. Yeah, the equation here is all the efforts are the same, but you know that F3 is F3 minus F2. So we need to sum the flows in here. So we were gonna do this over here. This in here you have that E sub 10 minus E6 is equal to E7. That's the equation. E10 minus E6 equals to E7. So what is it in terms of what is it written here? You see this signal for the F. This is coming like this, the other one is going like that. But it says on the once old forces are the forces add up and the velocities are the same on this one. So if the velocities are the same, you could do this and then this. Okay, so and then you have to see the we have the one in the I element, and here gets multiplied by 1 over s, gets integrated like 1 over s like this, and out comes this flow. That's how that one is. We were doing this over here, common effort, but we're going to add the flows like that. See? So this you have, this is E6 and the other one is F sub 6. And then at that point it says that all the flows are the same, right? This is what we did over here. All the flows are the same. No, this was the one for the one there.
Professor,
Yeah.
I think that's incorrect. That junction right there is incorrect.
This one.
That bottom one shouldn't have a zero, and the top zero you have, you can have the flow to. That's incorrect as well.
The efforts have to add. Oh, yeah. Thank you. I think we messed it up in here. This thing is not right.
The efforts add, that's fine, but the
Yeah, but even then it needs to go like this. This is the thing, but the flows need to add.
the effort comes out of the sum, and the flow drops down to the bottom.
This is what we are doing is in modeling. We are one on the left in
There's a
here.
one junction.
So that's why we have a problem in here. I think we need to,
Effort 19 comes out of the circle.
yeah, like this.
Yeah, and flow 19.
F19,
F19 goes in the bottom.
yeah, this is right. E19 goes,
Yeah.
and then F19 comes out,
Comes down to the.
but the flows are the same.
Yes, flows go down.
So this is wrong. Okay, well, I'm not perfect and sometimes imperfect, so this flow will have to go here, and this effort is gonna go in there. Yeah, so here's where we need to add this. But how do we do that? We need to make sure it follows the equation, like E19 is equal to E sub 6 minus E sub 2. Is that a 2 or 3? It's a 3, right?
No, 2.
So E19 is E sub 6. The way it is in here, E19 is E6 minus E3. E sub 6, which would be plus here and minus here. Okay, now let's go to the 0. All the efforts the same. So I think we're doing it with the red pen so we don't get confused. Bad drawing, very bad, because I joined both of those and that is not nice. So I need to go and you say all the efforts are the same. This is, and then this thing, the flows are gonna be like this. So we have, what is it written in terms of? This is in terms of E sub 7. Where do I have this in terms of E7 is? So all in terms of F7 is F10 minus F sub 6. F10 minus F sub 6 minus F sub, no, F10 minus F sub 6. Yeah, there we go. This other one on the top, we have, see that I element, and here gets multiplied by 1 over I 11, and then you have a gain of 1 over I, and then you do that. Then this SE that is adding in here, this adds an effort, but this is F16 smooth, but the effort is what's important. So in that junction all the flows are the same, so this has to be like this, eh? And then the efforts will add, so this will go here, yeah, and like that. But how should we add? We have that the E11 is E13. Let's see, how do we do this? Let's write it down. How does the equation right here? This says F11 is equal to No. E11 is equal to E12 minus E13 minus E sub 10. See, and is treating in terms of F11 or yeah. So we're trying to, on the one is F11 is F12 minus F10 minus F13. Not F. So if this is the case, we can draw over here the sign that these are E11 is, which one is positive? The first one, E12 minus E13 and minus E10. Minus plus. Yeah. So we are done with that, and then we have to go and do the ones on the side. So in here you see in that one the efforts have the flows are the same. Let's see, we are modeling the zero now, right? The zero. So this is the zero. All the flows will be the same because it's a, okay, wait a second. See, we are doing the zero junction, this one right here, that's what we're doing. So that zero junction in here, you have that E15 goes this way and F15 goes this way, and that F13 goes like this and E13 this way. Okay, and what about E14? E14 is, this one is the one, it's like this, yeah. So E14 is E16 plus E17. Okay, so recognize first what's common to that one junction. Or not to the zero, all the efforts are the same. So this has to go like this, and then this like that. But this is bad because it's passing through and it's confusing things right here on this. Yeah. So E13 is again for the summation points. No, it's E17 is the one that I am working on. And the other one that we had, we need to move it up a little. Maybe like that, see? See? And then on the one that goes down, you have the zero, and the flows will have to add in here like this. While on the one on the bottom, the effort up, flow down, yeah, and then E16, the effort is this way, and the other one like this. So in here we have what is that 14 bond is connected to is the effort 14, right? So this thing is like this. Am I right? Yeah. So what about down here? This is all flows are the same and the efforts will add. So let's see, float like this, and then we have the other one. And then you have the 16. Wait, 16.
19.
I have put the numbers. This is 17 right here and 17 right there. Then you have in here you have the R. The flow goes in like this, gets multiplied by R, and out comes E for the C element in there. Something is wrong here. The flows and the efforts are the same, but the one down here we have the flows are the same. So this will have to be like this. See? And I believe we have just two others to go. And on the bottom ones, just so that we do this a little faster, all the flows are the same on both of these structures. So in here you have that this connection goes like this. This connection makes a summation point like this. Yeah. And over here then the same way. Same kind of. And then this. There you go. And then finally we only have a couple of the elements on the R element. In here the flow comes in and comes out as E, so this you will have to multiply by R. This comes in and this goes out of the R, and that the effort in here will have to add. No. This branch of F9 is not correct. Or is it? I think we have a mistake. That one has flows are the common thing. Yeah, let me make sure that we get this right. So we are on the one junction in the middle of it. The flow comes in and the effort goes out. That we know for sure. The flow goes in and the effort goes out. It also is saying that in this R, the flows are the same, so this will have to be like this. Yeah, and that the flows, the efforts will add. There you go. and then the other one, the C element in here, F comes in, gets integrated, and this is 1 over S, and then this is the again we were talking about, this is the R. Yeah, no, I think I messed up. That's the C element, right?
Because the R.
Yeah, and that's the C element. So this thing is multiplied by 1 over C. Those little details that we have. I need to correct this. The flows were the same, but the efforts will add. And that is fine now. We were debating here, this is not R, but 1 over C here. This is 1 over S. Yeah, and I think still one more on the right hand side over here. Then this thing gets integrated and then gets multiplied by 1 over C 16, and out comes this. This other one over here, we do the same thing. This is R, but on the right hand side you have this, we have E is this way and F is this way, and this is 1 over S multiplied by 1 over C, and then we have finished the whole thing. Oh no. On the right hand side, I think there's just one more bond to do. Always in here, this is the source of flow. In here, this is this way. And then on this one, all the efforts add, but there's no more addition, and all the flows are the same. So that's where this is. Okay, I think our video might be in here. Let's see.